In the previous session, we have looked at characteristics of a function. Now let's look at different types of functions. Now this particular example, we had used this in our previous session. We'll be using it again here, but a bit later on. Now, the different types of functions are one-to-one, also called as injective function, many-to-one function, onto, also called as surjective function, into function, and bijective function. Let's look at them one by one. Let's look at one-to-one function. Recall the mirror analogy we had seen previously. Each person is an element of set P. Reflection is an element of I for image, set I. Mirror acts as the function. Using a flat mirror, every person gets exactly one reflection. But different people may look identical in some cases. Now, what if no two different people ever look the same in the mirror? Then, for every person, there will be a unique reflection. Then we say the mirror is a function. And if no two different people share the same reflection, the mirror is injective. Understand the difference? It's very important. Every person has a unique reflection function. If no two different people share the same reflection, mirror is injective. By choosing a concave mirror or a convex mirror, we are changing the function, or rather the way these mirrors form the reflection is different. So, which means f of P is not equal to G of P, where f is a flat mirror and G is either a concave or a convex mirror. Now let f map elements of A to elements of B. Then f is injective if A1 is not equal to A2, implies that their images are also not equal. Now here let's come back to this. Is this injective? In this example, is f injective? Remember one-to-one function? Here 0 maps to 0, or rather f maps 0 to 0, minus 1 to 1, 1 to 1, minus 2 to 4 and 2 to 4. Now here this is not one-to-one because you have two elements of A mapping to the same element in B. Now to make this injective, what do? We remove minus 2 and minus 1. Now you can clearly see that it is 1 to 1. Now let's look at the next type, that is many-to-one function. If there exists two elements, A sub 1 and A sub 2 in A, such that B is a mapping from A1 and mapping from A2. So here notice minus 1 maps to 1, 1 maps to 1. Similarly, minus 2 maps to 4, 2 maps to 4. Then it is called a many-to-one function. So as the name suggests, different elements of A may map to the same element of B. So clearly you can make out the difference between one-to-one function and many-to-one function. Now in case of the mirror example, if different people may have the same reflection, then we have many-to-one function. Now in this example, we do have a many to one function. Now let's look at onto function or surjective function. Here, for all B in the set B, there exists A in A such that f of A is equal to B. So in other words, every element of B is associated with at least one element of A. That is, there are no leftovers in B. So is this surjective? No. Why? Because -1 and -4 and let's say 9, they are not mapped by any element from A. So it is not surjective. Now to make it surjective, what do? We have to remove -4, we have to remove -1 and we have to remove 9. Now it is onto function or surjective function. Now let's look at into function. For some elements of B, there are no pre-images in A. So how do we make this an into function? For some elements of B, there are no pre-images in A. So let's include 9. Let's bring back -4 and -1. So now we have some elements of B which do not have pre-images in A. So 9, -1, -4 have no pre-images in A. So if for some B in the set B, there does not exist A in the set A such that f of A equal to B, then the function is called an into function. That means there are leftovers in B. So if there are leftovers, it is into, and if there are no leftovers, then onto. The final one, bijective function. Now this is a combination of injective and surjective. That is, f is 1 to 1 and onto. So now how do we make this bijective? Is it injective? No, it is not 1 to 1. Is it surjective? There are leftovers, so it is not surjective as well. So to make it bijective, we will have to remove -1 and -2 and correspondingly remove these arrows. And then we also have to remove 9, -1 and -4. Now here f is bijective. So basically what are we doing? To make it a specific type of function, we are customizing the domain and the codomain. Now let's summarize this. We have classification, idea, explanation and examples. So injective, 1 to 1. Different inputs give different outputs. The name itself makes it very clear, 1 to 1. So no two elements of the domain map to the same element in the codomain. And we have an example here. From f is a function which maps from the set of real numbers to the set of real numbers. And the rule is f of x equal to 2x. Surjective, that is onto, every element of the codomain is reached. That is, there are no leftovers. So each element of the codomain has at least one pre-image. Bijective, both 1 to 1 and surjective. 1 to 1 and onto. So every element of the codomain is reached by exactly one element of the domain. Many to one. Different inputs may give the same output. So several elements of the domain map to the same element in the codomain. And into, some elements of the codomain are not reached or used. So the image of the function is a proper subset of the codomain. So that was types of functions. That's it for now. Bye.